Hello, everyone. Thank you for joining me today to jump into Jetpack Compose way too early to see what's inside. So a little bit of disclaimer first. This is a lightning talk, so I can't possibly dig into every single thing the Jetpack Compose team has been working on, what I assume almost 2 years. And B, this is not a talk about the architecture or how you can use it or how to compose your view into smaller composable parts. If you're interested in those, you probably just come from the Pi room where Raghunath just talked about literally all of that. So I think the droidCon team will upload the slides and upload the whole recording very soon. But with all that out of the way, my name is Louis Choi. I work here in Berlin for erasys, and this is my Twitter handler. Why is it not loading? My laptop is loading, but the display is not great. This is exactly what you want a presentation to go. Perfect. Yeah, so back to topic. So yeah, if you want to know all about that, you probably just come from the Pi room where Raghunath talked about all of that. So with all that out of the way, my name is Louis. I work here in erasys in Berlin, and that's my Twitter handler. If that's your kind of thing, depends. Anyway, so let's get started. So a quick recap of what Jetpack Compose is. So the goal of Jetpack Compose is to simplify UI development after 10 years of we have all been using views and all the crazy stuff that Google and everyone has built. And they are trying to achieve that by providing what they call a declarative programming model, heavily inspired by React back in 2013 and subsequently Flutter, Vue, yada, yada, yada. And they are trying to accomplish that by building a completely new set of unbundled toolkit heavily powered by Kotlin. And this is a very simplified version of what it looks like. You have completely new import. They are not views anymore. And then somehow, magically, you write a function, you put annotation, and everything works. You should be able to, let's say, my name is Louis, so you should print out, hello, Louis, welcome to droidCon Berlin 2019, somehow. So in terms of the whole thing itself, the toolkit comprises of 3 main components: the runtime, the compiler plugin, and I'll talk about what this tool does in a minute, and the tooling. So if you are brave enough to check out the source code right now, you realize that the tooling is not necessarily the best. The compiler, like Android Studio, complains everything every single second, and they are aware of that. It's just that they want to at least get it running in some sense. So if you have any ideas, let them know. You like what Swift UI is doing, let them know. They probably keep it in some notepad somewhere. So okay, yeah, back to the question. I think I put it in the abstract as well. So if it's not a view, it's not a fragment, then what the hell is it doing? How does something get actually rendered onto the screen? So if I have to summarize it in one sentence, it's not a good first summarize, but I will call it composable functions that knows how to draw. So let's take a look at one of the most used component we use every day, text view. Who don't use text view on a daily basis, please raise your hand. Thank you. So in traditional text view, ultimately what happens is that the view has an onDraw method, somehow gets a canvas, and it uses the canvas to draw everything. And in the Compose world, what happens is that the text function invokes a draw, also a function that somehow magically gives it a canvas. And then with that canvas, it does the traditional drawing. It's just that the extra benefit is that now all the font support, size, text, all the random things are baked into the toolkit. So supposedly, we don't have to wait 4 years just to get a left and right or something. So yeah, long story short, somehow it gets a canvas to draw. And the most important part, in my opinion, is that this whole thing is the fact that it's composable. In real world, you won't be doing this with the draw component like 99% of the time. Usually what we do is put some buttons, a button says drawable, and some label, and then maybe it's a list which also only has text and image. That's pretty much like half the app on the Play Store does. And that's what the composability comes in. It makes it much easier to put things together, and you no longer have to try to figure out, oh, why does the button inherit from a text view and all the kind of random stuff. You try to pick one thing to extend from. But instead, you can very easily just spam 2 things together, bam 4 things together, bam 200 things together if you want to, and somehow they work. And now, let's look into the very basic idea of like what the composer function is. Simplified version, this is the syntax. It's a function. It has an annotation, and it returns nothing. Well, not nothing, but you get the idea. And we just explained a little bit about how it magically got the canvas. And since the text thing itself draws things onto the canvas, what does the return value mean? Like if you, especially you have experience with Flutter, we just have a great talk here, and or React, that usually you return something so that someone else will render that for you. But since right now, the component itself is in charge of how to write stuff, so everything is just a side effect onto the Android view. Well, not Android view, but something onto the screen. So in that sense, the return type doesn't really have any meanings anymore. And the mental model, which Raghunath also talked about, to understand how this side effect works, to simplify it, is kind of similar to print line works. Whenever you call print line, you kind of have like a hidden contract, say that someone will be able to print this text for you. I don't know who, I don't know how, someone will do that for you. Composable function, this side effect is in a similar manner. As long as you invoke it in the right place, someone will give all the canvas or service view or those low-level graphics API it needs to draw whatever it needs to draw. So now we got like touch on the very elemental part of how one component draw. Now let's look a little bit on the runtime. When you have multiple things chained together, tied together, composed together, how do they interact with each other? So again, I have a very simple, primitive version of the app built with last week's version of Jetpack Compose, and I think the code already broke. Anyway, so on the left, you can see if you do it in traditional Android, it's a linear layout, vertical to text view. And on the right-hand side is how you would do it in Compose. I omit the styling part because they're way too long. So one detour I want to mention is that what Jetpack Compose brings is the ability to have code very, very similar to your UI. Like in the last few years, we use a lot of constraint layout. We really like it. We are actually being able to easily make layout understandable. But then when you get a pull request on a constraint layout with 200 lines, it's going to be hard for anyone to try to figure out what the hell is going on. So with this kind of programming, declarative programming model, we are bringing us back to the world of the code. It's very similar to the UI. Okay, enough detour. Let's go back to here. So again, your right-hand side is the code, your left-hand side is the view, and now how does it run through the function? So imagine this whole thing is just a tree, and since it's Kotlin code, so the beauty of this whole thing is there's not really any magic. It literally runs a function like a function, aka you can put breakpoint in every single line in there and it will stop at exactly the right time. You no longer have to inflate a layout and then something broke and then you have to figure out what exactly to then make a typo or some like on left or right or something missing. So when it goes to the first line, it runs the function, it does whatever it needs to do. If between the line app and column you want to log anything, it does the same. And it goes to column lines. So what happens is that there's essentially a composer at the very top. He's just in charge of pointing to the whole tree to see which part should I render. So it originally points to the app node, and then now the app node said, okay, I'm done. I'm gonna tell the composer to now point to the column, And then now the column is in charge of doing what it wants to do. It probably do some math to see how big it is, so that it can fit whatever is student inside of it. All the calculation is done, and you invoke the lambda. And then that means it's the point for the column to tell the composer to say that, okay, composer, please render whatever my student says it wants to render. And that's essentially how the whole chain goes through. No matter you have three layers, 10 layers, 2 million layers, that is like the mental model of how this whole thing goes through the whole tree. So right now, it goes to the node hello, and once it's done, it will tell the composer back, okay, I'm done. Now please find parents and ask my parent what to do now. Like, I'm just a child, I don't know what's happening. And then the column will say, okay, this child is done, like don't care about it anymore. Now go to the next children and do something with it. And this is how it goes through multiple children in like the single like composable function. And last but not least, everything is done. It finished like a function. It goes all the way back to the top. And then that's how essentially one frame got like render. So, okay, now I have a little bit of concept of what the runtime is trying to do. Let's look a little bit more about the syntax again. So, function. Android traditionally have views, and especially if you have Flutter or React experience, don't be scared about the JavaScript. You'll know that they usually extend from some kind of class, and then there's a function you have to override to say, this is the thing I want to render. But then why does it not use a class just like everyone else? Again, same slide as the talk from Raghunath. So the whole premise of declarative UI is what we want is UI equal function of state. And from the last like 6-ish years of people like playing with React and seeing what it can do, what it cannot do, we realized that, okay, maybe component is not small enough. Maybe in some cases, there are other ways to deal with it. So this is kind of messy, and that's kind of the point. So at the very bottom is the thing that what we actually want to render is the whole render function that returns the thing that wants to be seen. But then you suddenly have some hook into listener and then unhook from listener, like if you use Redux, you're hooked into the store or something, and then you have some state, like it starts to get everywhere. And when you write it, it's okay. And then when some bug starts to happen, you try like, oh shit, what the hell is happening? Like, who exactly changed this state? It starts to go through a lot of random places just to find what the hell is happening. So in last year, React introduced a new thing called React hooks, essentially breaking down the component back into multiple functions. Again, not going to show too much JavaScript, but this is the visualized version from this great guy from Twitter to animate this. It makes it much easier to move relevant code snippet back into the same place. All the state management to this side, all the lifecycle thing to this side, and all the other random business logic, well, you should probably extract them out anyway, just turn them into normal function that you can just call anywhere. No longer they are encapsulated by a component, by a class. They are now just like a thing that you can use anywhere. So this would be a great segue to how Jetpack Compose is using this kind of concept to deal with state management and lifecycle stuff. And here's the catch. Right now, if you come from Raghunath's talk, there's kind of two ways of dealing with state already. The model annotation and the plus memo thing, which is definitely a thing that the Jetpack Compose team is still trying to figure out the right way. And they're also having the third way, which I think is trying to have composable function with actual return types to put what they call effect and composable function back together. This whole field is just like completely experimental. So like no matter what I put in here in 2 weeks, it's going to be irrelevant. So if you check it out, like it's great for you to check it out, but please be aware that the state part is extremely volatile right now. And if you don't want to care about it, just remember what the Google I/O did with the model annotation and pretend that's what's going to happen. So yeah, I don't have much time. So the last thing I'm going to talk about is the annotation. So people don't like annotation for like legitimate reason, like they make compile time slow. The annotation processor has been not great. And yeah, so why do we still have it? So there are multiple reasons the Jetpack Compose team decided to go this way. So problem number one, we need to be able to identify what is normal function and what is a composable function. I can't just randomly expect have like a pure Java code calling a composable function and expect something to render. That should be a compile time error. And yeah, so that's one thing they're trying to do. And so in that sense, it's quite similar to how suspend function in coroutine works. Not just in the mental model, but actually in the implementation as well. So actually, the composable don't hook into annotation processor. It actually hooks into the new, also very experimental Kotlin compiler IR. So what it means is that you write Kotlin code here, you have bytecode at the very end. Traditionally, it's just a Kotlin compiler go all the way there. Now they add a layer in between, so what they call Kotlin intermediate representation. So Kotlin code to intermediate representation, a lot of magic happening there, and then to bytecode. The original reason why they created that so that they can turn the IR into multi-platform bytecode, JS, and native code. But now the Jetpack Compose team and the coroutine is doing the same thing. They are modifying the intermediate representation layer to do all the crazy things inside of there. So what crazy things are they doing in there? Mostly optimization and performance. And it goes all the way back to the goal of the project is to simplify UI development, is that we don't want people to have to write a million caches here and there just to make things performant. And with this kind of declarative UI, like it goes through this whole thing. But are phones this fast? I don't think so. Like you probably don't have an app only with 3 nodes. You probably have 1,000 nodes, like in a million places. So let's see what the compiler can do to help it out. This example again, but imagine this is not an app. Imagine you have a list of people like Office. So that means a lot of the things are going to be repetitive. So how can we make it run better? First thing, very obvious, this name, the text name thing, it got rendered. It should only get rendered once. It never changes. Like maybe it got GC or something, but it should not be rendered unless it's like absolutely necessary. So that's one thing the compiler do is put a hint in there and say that, okay, cache that as long as you can, just there. Try to stay there as much as possible. And another thing they're trying to introduce is the concept of grouping, especially in a list. Especially if you use div util, you have to identify which item is which, and it's kind of the same concept. If you have a list, you want to identify which text username you're trying to do, it would be better to have a concept of grouping so that next time when I do the cache lookup, I don't have 10 author and 10 username to look up. I can use a key to identify exactly the author I'm looking for and then find the text inside to update it. So I think I'm running out of time already. So last thing is there are a lot of great resources. Special shout out to the Compose channel on the Kotlin Slack. Since the very first day, they have give a lot of like useful information, and the reason why they are all this is because this is easier to take pictures from, I guess. And yeah, the Compose channel has been very helpful, and even just React and Flutter concept, they are also to like give some explanation on why they do things in a certain way. And also Flutter, React, and Vue and Litho, people have spent 6 years working on these kind of projects. There are a lot of lessons that they have learned, so those are also great resources. And so that would be it. Thank you very much.